So we are going to go through the test corrections for the Pre-cal Chapter 0 test. And so what you're going to need is a corrections and error analysis form. They are blue and they are found in the classroom next to where you turn in your tubs. Okay, so you will need to fill out your name, what period you're in, the test. This is a test and it's the Chapter 0 test. You don't need your parent's signature unless you made a grade below a 59. These will be due 3 days from the date the tests were entered into the grade book. So if you took your test last Friday, the 11th, then they would be due Wednesday, the 16th. So we're going to go through these problem by problems, and so I'm going to do them one at a time. So I'm going to be flipping back and forth between the correction form and the actual test. So problem number 1, it asks us to use set notation to write the elements of each set, then determine whether the statement about the set is true or false. And so our question here is that L is the set of whole number multiples of 2 that are less than 22. So whole numbers are from 0 out. So 0 times 2 is 0. 2 times 1 is 2, and 2 times 2 is 4, and we're going to go all the way out to numbers that are less than 22, which would be 20. So the second part of this question is part B, then asked is 18 an element of L, true or false? Well, I don't see 18 in my list, but if I continued counting by 2's, 18 would certainly appear before 20, and so that is true. So my new answer then is L is equal to the set of 0, 2, 4, ... all the way out to 20. And for part B, the answer is true. So there really isn't much work here to show, but you might want to remember that whole numbers, the set of whole numbers, begins with 0. So you have to analyze your error there. Okay. Question number 2 says, let C equal the set 0, 1, 2, 3, 4, and D equal the set 3, 5, 7, and 8. And F is the set, E is the set of 0, 1, and 2. So the first question says, find the intersection of D and E. So intersection means, what do D and E have in common? Well, D has 3, 5, 7, and 8, which are not in E, and E has 0, 1, 2, which are not in D. So the intersection of D and E is the null set or the empty set. They have nothing in common. Part B is C union E. So we're going to put C and E together. What are all the different elements in C and E? So I have 0, 1, 2, 3, 4 in C, and I have 0, 1, and 2 in E. Well, those are already contained in C, so the union of C and E is simply the set of 0, 1, 2, 3, and 4. It's all the different elements together in one set from the combination of C and E. So on the error analysis form, the correct answer for part A was the null set. They have nothing in common. And part B was the set of 0, 1, 2, 3, and 4. So there really, again, isn't much work to show here. If you wanted to show that there was nothing in common, that might be a concept to remember, that this is intersection, meaning what do they have in common? And then U is union, and so you're listing all the different elements there. Okay, question number 3. It says to simplify the next following problems. So the first one we have, I'm just going to copy the problem onto the paper. So in number 3, we have 6 plus 5i plus negative 3 plus 2i. So since it's addition, all we do is I'm going to slide the second set of parentheses underneath the first, lining up my like terms. So I have a minus 3 and a plus 2i. So all I did was slide that underneath. And now I'm going to add up my columns of like things. So 6 minus 3 is 3, plus 5 plus 2i is 7i. So that is my new correct answer. And then you'll have to analyze where you made your error in number 3. I'm going to go ahead and put 4 on this page because I've still got some space here. So question number 4 was the product of negative 3 plus 3i times negative 2 plus 2i. So we're going to FOIL this out. Negative 3 times negative 2 is 6. Negative 3 times positive 2 is negative 6i. Positive 3i times negative 2 is negative 6i. Positive 3i times positive 2i is a positive 6i squared. So remember, in complex numbers, we never have I to any other power other than 1. If it is to another power like this, we have to use our I chart to simplify. So I have 6 combining like terms is minus 12i plus 6 using the I chart. I squared becomes negative 1. So 6 minus 12i minus 6 is equal to negative, or 6. Did I miss something? No. Okay. So 6 minus 6 is 0, and so I end up with negative 12i as my answer. So again, you'll have to analyze where you ran into problems. So that will be up to you. Okay, there is a backside if you need it. So remember, you're only correcting the problems that you missed. So problem number 5, we have 3 plus I over 5 minus 2i. And again, we're being asked to simplify, which means that we're not allowed to leave this complex number in the denominator. So we're going to multiply by a form of 1 so that this will be changed from a complex number into a real number. And so in order to do that through multiplication, we have to multiply by the conjugate of the denominator. So it's the same 2 terms, but we change the sign in between. So if we're starting with a negative, it's now a positive. Remember, we're creating equivalent fractions, so what I do to the top, I have to do to the bottom. And so now we're going to multiply these 2 things together. So 3 times 5 is 15. 3 times 2i is 6i. I times 5 is plus 5i. And I times positive 2i is plus 2i squared. Going through the same process in the bottom. 5 times 5 is 25. 5 times positive 2i is plus 10i. Negative 2i times 5 is negative 10i. See how they're going to drop away? And negative 2i times positive 2i is negative 4i squared. Let's combine our like terms and change the I squareds. So I'm going to have, I'm coming down over here, so I'm going to have 15 plus 11i plus 2 times negative 1 over 25. The i's cancel, minus 4 times negative 1. So we end up with 15 minus 2, which is 13, plus 11i over 25 plus 4, which is 29. So my final answer is 13 plus 11i over 29. Number 6 says determine whether the function has a maximum or minimum, then find the value of the function, find the value of the maximum in for f of x equals x squared minus 5x plus 4. So the easiest way to do this, of course, is on our calculator. So I am going to create a new document. I'm not going to save what was previously there. I'm going to look at the graph. And so I'm going to type in my equation. So I hit, oh, it's already there. Okay, so I'm going to type in x squared minus 5x plus 4. Why isn't it typing? So once again, x squared minus 5x plus 4 and graph. So I can see that it's a parabola that opens up, and so I end up with a minimum. So you might want to draw just a basic parabola here. And so this is a min. And so to find it, I'm going to use the menu. I'm going to go to the menu, and I'm going to analyze the graph. And I'm going to find the minimum. So now all I have to do is trap the minimum in between the dotted lines. So I'm just going to scoot over here and click in the center. Come on. My battery's low. My battery just died. Okay, let me try on this one. X squared minus 5x plus 4. Enter. We have a minimum. Menu. Analyze the graph. We have a minimum. So all we want to do is get the minimum in between the two dotted lines. And so here it is. If I get my hand to open up, I can click and oops. Control click. Move this out of the way anyway. Okay, so there's our minimum. We have it at 2.5 and negative 2.25. So that would be our minimum. Negative 2.25. So those are our answers. We have a minimum at 2.5, comma, negative 2.25. And again, you need to analyze where you ran into trouble. Number 7 says to solve x squared minus x minus 20 equals 0. And so there we talked about many ways to solve this. If you factored it, you're looking at two numbers that will multiply up to the product a times c, or 1 times negative 20. And at the same time, they have to combine to the b value, which is negative 1. And so those numbers would be negative 5 and 4. Negative 5 times 4 is negative 20, and negative 5 plus 4 is negative 1. So those are my factors. X minus 5 times x plus 4 equals 0. And then to actually solve it, I set each parenthesis equal to 0 and solve for x. So x minus 5 equals 0. Add 5 and I get x equals 5. And then x plus 4 equals 0. Subtract 4 and I get x equals negative 4. So those are my two solutions. X equals 5, x equals negative 4. Those could have also been found on the graphing calculator. If I had just typed in the equation, x squared minus x minus 20, and hit enter. If you remember anything from last year, these are my roots, my zeros, or my solutions. And so that looks like they're crossing right at the tick mark, so I can see 1, 2, 3, 4, 5, and -1, -2, -3, -4. And of course, you can do these through the menu, analyzing the graph, and we're going to look for a 0, and you do the exact same thing. You're going to trap each one in between, and so there's one of them. So we can see there's 1, there's 5, 0, and then I would have to go through the menu again and analyze the graph to find the other one. So I scoot over here. And of course, we're going to find -4 here. So there it is. So you could have found the zeros that way, through the graph, through factoring, or through the quadratic formula. So number 8, it says to simplify, and we have the 6th root of x to the 12th, y to the 15th. So remember, you're thinking index goes into the powers. So 6 goes into 12 2 times. So that means 2 x's get out. There's a remainder of 0. There are no x's left underneath. 6 goes into 15 twice. But it has a remainder of 3. So that means we have y to the 3rd left underneath. Number 9, it says simplify again. And so we're looking at the cube root of -64 over 343. Again, this has no variables in it. It could have been done on the calculator very easily. I'm just going to calculate it. And so I'm going to type in the cube root. And so that is found, which you can't hardly see, but it's on the power key, but it's in yellow. So control power. Oops. Somebody's got some other stuff in here. Let's see. There we go. Try this again. Okay, so control power key, and it's waiting for me to type in the index. It's just 3. And then I'm going to have negative. Make sure you're using that negative key down here below 3. So -64 divided by 343 and hit enter. And you came up with -4/7. As long as there's no variables here, you can simply type in the calculator to find it. And then finally, number 10 says solve by elimination or substitution. So 3x plus y equals 4, and x minus y equals 12. If you did elimination, the y is automatically eliminated, and so you ended up with 4x equals 16, and x equals 4. So plugging it back in there, I have 4 minus y equals 12, and so -y equals 8. Divide through by -1 or multiply through by -1, and I end up with y equals -8. So that would have been through elimination. If you did substitution, you probably used the second equation, or you could have used the first one to solve it for y. It doesn't matter which equation you use. I'll just use the first one. So I end up with y is equal to -3x plus 4. So I'm going to replace y in the second equation with this. So I'm going to have x minus -3x plus 4 equals 12. Distribute the negative, so x negative times negative is a positive. Negative times positive is negative. Collect up my like terms. 3x and x is 4x. Add 4. And so x is still 4. And then again, I can take this and plug it in right there to solve for y. So I would have y equals -3 times 4 plus 4. And so y equals -12 plus 4. Oops, -12 plus 4, which is -8. So my solution then is 4, -8. So you'll have to analyze your errors to fill in the final column. This is how you'll get credit for your corrections. So remember, it's about the concepts and the procedures to remember. It's not, I forgot. Okay, so remember, you want to list the concept or procedures here. All right, good luck on your corrections.